Okay, we'll get started. In this section, we're going to be looking at vertical kinematics. So what that is we're going to be taking what we know about kinematics in the horizontal directions, and we're going to be applying that to up and down instead. So we're going to be looking at the same kind of procedure, the same equations that we use in the horizontal direction, but there's going to be a couple key differences to keep in mind. So again, same ideas as horizontal kinematics, but a couple important differences. The first is that to realize that when you're dealing with something in the vertical direction, you're going to get objects that tend to accelerate towards Earth, right? They're going to get pulled down towards the Earth, and that's going to be because of gravity. So gravity causes objects to accelerate towards the Earth. And that acceleration is going to be constant, meaning that it's always going to be the same value on Earth, constant, and it's going to be negative. So negative in this case would mean towards the ground. So constant and negative towards the ground. The acceleration, the actual value of this acceleration is going to be this number right here. It's going to be negative 9.8, and then it's going to be meters per second squared because that's the standard unit for acceleration. So again, objects that are accelerating in the vertical direction are going. The reason for that is going to be because of Earth pulling down on them, and it's going to have this value right here, negative 9.8 meters per second squared. Now it's also important to keep in mind that unless otherwise stated, we're going to assume objects are in free fall. Now what that means is that we're only going to be concerned with the effect of gravity on them. We're not going to be concerned with air resistance. Air resistance is going to basically slow how fast objects are accelerating downwards, and it's going to change depending on like the property of the object. Like certain objects are going to have more air resistance than others. So, and again, unless it otherwise states, don't worry about air resistance. You could just assume that the only really source of acceleration is going to be gravity. So again, unless otherwise stated, assume objects are in free fall, meaning that it's really just gravity you have to worry about in terms of acceleration. And the last thing to realize really is what velocity, the velocity of an object that's being influenced by gravity, being pulled by gravity, that velocity is never going to be constant. So again, if you throw a ball up in the air, if you throw it down, if you drop it, the velocity is always changing, and that's because there's an acceleration happening on it. So again, the velocity of an object in free fall, meaning an object that's really just under the influence of gravity, its velocity is always going to be changing, either speeding up, slowing down, but it's never going to be constant. The last thing to realize is what initial velocity, how that's going to be a little bit different in the vertical direction. So if you have something in the vertical direction, you could either throw it up, throw it down, or you could drop it. Right? Those are I guess you could do other stuff, but those are the situations we're going to be looking at. Throwing it up, throwing it down, dropping it. So if you were to throw an object up, its velocity, or not its velocity overall, but its initial velocity would be positive because that's a positive direction. So again, if you throw an object up, that's going to have an initial velocity that's positive. Its acceleration is still going to be negative because that's always going to be negative because it's the Earth pulling it down. If you did something different, if you threw the object down, its initial velocity is going to be down instead. It's going to be negative. So again, you throw an object down, its initial velocity is going to be negative instead. Its acceleration is still going to be the same way. And if you drop an object, its initial velocity is technically 0. Because it will start moving, because there's a downward acceleration, but it's going to be initially not moving. It's going to have an initial velocity of 0 first. So that's important to keep in mind, right? What does initial velocity mean? Right, thrown up, positive, thrown down, negative, dropped, it's going to be 0. And the last thing to remember here is that down, left, west, and south are all negative directions, but they're not the same direction. Now, what do I mean by that? Well, if you saw something like this, negative 5 meters a second, this number, or this, this value, the negative could mean any of these directions technically. So just because you see negative doesn't mean it's one or the other. It could be any of these. You have to kind of read the problem to figure out what that negative means. So the important thing to keep in mind is just because you see negative 9.8 meters per second squared, that doesn't necessarily mean, don't just automatically say, oh, this must mean left or this must mean west. Think about the situation. Don't always assume negatives one direction or another. Okay, that's the notes. So again, important thing, just remember that everything in vertical kinematics is still valid, just there's going to be some additional things to think about when you're dealing in the vertical direction as opposed to horizontal. So let's see a problem with this. There we go. So again, before I solve it, make sure you do it out first. Again, if you're stuck, remember, like I just said, you can use all the same equations. It's the same procedure to solve this as you did in the horizontal problems. Okay, we'll go through it. So what do we have? We have a tennis ball is dropped off the top of a building. What is its change in position after 3 seconds? So this is what's happening. Ball dropped. And it's asking what is its change in position after 3 seconds. So what is this? Its change in position right here. So that's our unknown. So what is the displacement or the change in position? There's just two ways of saying the same thing. Now we got to find our knowns. So if it's dropped, and I bolded it just to draw your attention to it for the first time, if it's dropped, the initial velocity is 0. The acceleration is going to be the same value it always is for a situation like this. It's going to be negative 9.8 meters per second squared. That's because it's gravity that's pulling the tennis ball down, so it's always going to have that same value. And then the last thing that you can figure out is the time. So it's saying after 3 seconds what happens. So 3 seconds. So now we need to figure out an equation that'll solve for delta x using stuff that we know. So we have this one is the easiest. It's not the only way to solve. This is the easiest though. So we know we're looking for delta x. We know vi, t, a, and t again. So we're going to do delta x is what we're looking for. Vi is 0 times 3t plus 1/2 times the negative 9.8 times, maybe I'll put that in parentheses, times what? 3 squared? 3 squared. So we're just going to solve now. So we're going to delta x is equal to, this is going to cancel, but let's just punch this into the calculator. You punch that in the calculator, it is negative 44.1 meters. So let's think for a sec about the answer. Does it make sense that it's negative? Yes, it does, because you're ending up lower than when you started, right? It's going down. So that would make a sense that its change in position is negative. So that's reasonable. And meters, the standard unit for displacement. So that's the answer. It's important to realize that it's the same thing as horizontal kinematics with a couple, key differences. But you're still finding known, you're still finding your unknowns, or you're still writing down your unknown, you're still finding your knowns. You still need an equation, you still need to solve. The big things that are different are realizing that the initial velocity is different, that the acceleration works a little bit differently. But other than that, it's really all the same ideas. So again, make sure you have this copied down, the solution in the notes, and that's it for now.